Okay, this problem requires you to do that long process by using the Riemann sums. So the very first thing that you want to do with this kind of problem is to find the delta x and the CI. So delta x, let's do that first. Delta x formula is b minus a over n, and this is equal to 3 minus 0 over n, which is equal to 3 over n. So that's going to be your delta x. The next thing we're going to find is your CI. So CI is equal to a plus delta x I. And so for this kind of problem, the a, here's your a and b for each one of those. A is 0 and b is 3. So we're going to do 0 plus delta x we just did up above, that's 3 over n, and then I. So then if you simplify that, you get 3i over n. So the next thing we want to do is to put it into the Riemann sum formula. So hopefully by now you have this problem written down. It's also in your sample test. So I'm going to go ahead and erase this so we have enough space to do this kind of problem because it requires more space. So with these two things, we're going to put them into the Riemann sum formula. Let's do the Riemann sum formula first. So it's the limit. We have this summation I equals 1 to n f of CI times delta x, like that. We have to put this information into here. So the next step is going to be, it goes to infinity, summation I equals 1 to n. That's going to be f of the CI, 3i over n, and then times 3 over n, like that. This part is what we need to do next. We have to find f of 3i over n. Now the original f of x was 9 minus x squared. So you're going to put 3i over n into the x in that equation. So next thing we'll do, we'll put that in. So summation I equals 1 to n. We have 9 minus, and this is what it'll look like, 3i over n squared. And then we have 3 over n right here. So again, it's just your 9 minus x squared formula. You take out the x and put in 3i over n because that's your CI that we did earlier. We can simplify this, square the top and the bottom. So limit n goes to infinity. We have summation I equals 1 to n. And then we're going to get 9 minus 9i squared over n squared. And then right here you've got 3 over n. Okay, so now we have it ready to multiply out. So at this stage, we're going to multiply each of these by 3 over n, and that's going to be our next answer. Okay, so we have the same thing, the limit and the summation again. We're going to multiply each of these out. Multiply this, you get 27 over n minus 27i squared over n cubed, just by multiplying, distributing each of those. Now at this stage, you want to separate each of these and apply the summation to each of these individually. And the idea here is by doing that, eventually you're going to apply a summation formula to each of those separately. So now let's separate that. We have the summation I equals 1 to n of 27 over n minus summation I equals 1 to n 27i squared over n cubed. So we're applying a summation to each of those. Before you can use the summation formula, what you want to do is anything that has an n, you want to move that out front of the summation. So for this one, I can move a 1 over n out front, and then this one I'm actually going to take the 27 over n cubed out. I want to leave the I squared there because I know there's a special summation formula for the I squared. There's also a special formula if I have just a constant there, and I'm going to apply those after I take out the n's. Okay, so next we're going to take that out. So this one we're going to do 1 over n, summation I equals 1 to n of 27. Then minus this one we're going to take 27 over n cubed, summation I equals 1 to n of I squared. Now we're at the point where we're ready to put in the special summation formulas for each one of these. So I'm going to go ahead and put that up here. So hopefully you have all this written down. I need to continue that, have enough space to write that out here, so I'll put that up there next. So kind of continuing off from this step, put that up here. Now the 27, if you have a constant in there, one of your summation formulas says you take the constant and multiply it by n. So this is going to be 27n right there. Next, you have minus 27 over n cubed. We're going to put the special summation formula in for the I squared right here. So basically, both of these that have boxes around them like that, each of those turn into special formulas that I'm doing up here in this step. So all that right there turned into 27n. All this here, I'm going to put into the next one on that. And so now we're going to put in the expanded version of this, 2n cubed plus 3n squared plus n, all that over 6. So that's the special formula that you're going to use there. So now it's just a matter of finding out the limit. I've gotten rid of all the summations. Everything's all in terms of n's. So now I just need to simplify. So the n's here, I can cancel those out. And also, right here, I can divide each of these by 3. So this will be a 2, and this is going to be a 9 up there. So in the next line down, I'm going to take this 9 is really times everything through. Now there's a minus sign in front, so I'm also going to distribute the minus sign through all those as well. You don't want to forget about that because all those will turn negative. So the next line, we're going to have just 27 only. That's it for that. And I have a minus 9 times all of this here. So we're going to have on top here minus, we have a for that one minus 9 or 18 should be. So minus 18n cubed minus 27n squared minus 9n. So we're doing all that. Now on the bottom we have 2n cubed. What I'm going to do is just write that underneath each one. So that's technically what you're doing here. You're breaking this all up. So you distribute the minus 9 all the way through, but then because there's a 2n cubed that's on the bottom, this is what that means. Everything on top will be divided by 2n cubed, and you want to do that so that way you can simplify everything down by doing that. Now we're going to reduce all this and then take the limit. 27 minus 9 you get for that first part. Then the rest of this, you have minus 27 over n and then minus 9 over 2n. Now when you take the limit as n goes to infinity, anytime you have a number over a variable like that, n raised to a positive power underneath, these two are going to go away, turn into 0. So your answer is just going to be 27 minus 9 minus 0 minus 0. And then if you do all that, you get the answer of 18. So 18 would be the exact area underneath the curve 9 minus x squared between 0 and 3. We do this by using the limit process Riemann sums.